I was just like, why am I going to play games? Just
do you also sing on this mic?
I could sing on this mic.
Do you want to take over this call?
Not with singing, I don't.
Okay.
What kind of input method do you have?
It's going, I mean, this is not a great system. I'm using a Focusrite Scarlett. Let me look at it. 2i2. No, 2i2. Okay. I don't have, I mean, I take this stuff kind of like, you know, I'm like a pro amateur. Like I want to use stuff that isn't horrible, but I also don't want to spend money on a real system that I'm never really going to fully utilize. But it's going into a Windows machine, and it turns out that the Focusrite drivers. So I had another Focusrite device, and its drivers for Windows 10 were hot trash. So I bought another Focusrite device, and its drivers are also still hot trash. So it's a driver issue, but it's not a very good interface because of that.
I see.
Well, it sounds good.
Maybe the problem is that Windows is trash. It's not.
Yeah.
Well, yeah, that's what I meant. Yeah.
All right. On that note, thanks for sharing the alpha leak on the latest project. All right. Yeah, welcome everyone to our MEV research workshop. Just like every other Flashbots research workshop. Sorry for the late notice. It's going to be unfortunate, the nature of this, because we have so many great research questions to explore. And it's always hard to figure out which ones are the best one for this particular session. So for this one, we're going to dive deeper into auction mechanism design. And our MEV fellow from our first batch of MEV fellowship, Soraya, please go ahead, and I believe you have done some preparation, and feel free to screen.
I've got some slides I could talk about, but first I want to sort of like introduce, I think, the overarching question that has come up as, I think, the driving force behind realizing what an MEV Geth auction would look like. So one of the issues that I think Tina and Alex have really identified comes down to what do bot operators want to actually, come on board and take part in such an auction. So as we all know right now, a majority of these auctions take place in the mempool in the form of PGAs where, like all the information is public and where, bot operators over time can adapt their strategies to how others are behaving. Now, the general theoretical holy grail of what most auctions end up being in the crypto space is second price sealed bid auctions. But it has become clear that really what bot operators want is to not have to, is to not be subject to this sort of, truth telling and, paying really what other people value. What they want is more transparency in the auction to actually be able to observe other people's bids, other people's strategies, and then bid according to that. So with that, I will share my slides and hopefully this will lead to some good discussion. Let's see, how am I going to do this? Present. Okay. Can you all see this?
Yep.
Okay, cool.
Yes.
So the first question really that that's on the screen now is exactly this, right? So do we care more about having a sealed bid second price auction where where the incentive is truth telling and where we can at least attempt to maximize the revenue that a auctioneer, or in this case a miner, might receive? Or is it better to really use an alternative where sealed bids are not, where bids are not sealed, where we release information about how people are bidding, perhaps in the form of rounds? And this sort of, I think, leads to the next more important question really is that, a problem in this space really comes down to, auctioneers can also be malicious, right? So if I'm a bot operator, my concern is going to be that if we're dealing with sealed bid second price auctions, in reality, the auctioneer, the miner in this case, wants to, of course, earn as much as they can always inject their own second highest price bids and sort of influence how much everyone ends up paying, right? So from the point of view of bots who are actually, taking part in these auctions, there's a concern there that miners can arbitrarily influence the auction, and so they end up paying more. So the question really comes down to is, do we want a second price auction, or do we want to perhaps sacrifice on miner revenue for the sake of having a first price auction where such sort of a manipulation on behalf of the auctioneers is no longer possible? And under certain cases, the argument can be made that, for example, imagining that all the bidders' valuations are sort of drawn from a uniform distribution, one can say, okay, like an expectation, both in first price and second price auctions, like an expectation, the miner will earn the same amount of money, right? But of course, that assumes that these valuations are independent, and if they're not, then of course second price will yield slightly higher auctioneer profit. So from there, like if we do think that first price auctions are the way to go, where bots can have a little bit more trust, more faith in the system, then the question moves to, okay, if we're going with first price auctions, should we consider a touch auction? So the trade-off there are really are quite simple, actually. I mean, in first price auctions, auctioneers really don't have to do any work at all, right? Like they just have to wait and select the highest bid, and they're happy. In a touch auction, though, the miner has to do some extra work in setting, the highest price, the starting price of the auction to be high enough that it's more than the maximal extractable value of some transaction ordering opportunity, but it has to be not so high that these auctions take forever to actually yield some sort of a winner. And of course, as we know in practice, like even though in theory the Dutch auction and first price auctions have equivalent strategies, in practice, Dutch auctions actually yield higher revenue for miners. So with that, I think the main questions I want to drive the discussion from here is whether this concern of malicious miners is relevant, whether it is significant, and whether it's worth considering non-second price auctions and taking the hit in terms of how much actual revenue miners are going to earn. And this all sort of, I think the high level question is, we want to move as much of the auction behavior out of the mempool and into the MEV-Geth auction, and so how do we encourage that adoption the most? And once we have adoption, of course, we can update the how the auction works, but at least at the start, these concerns are worth addressing for bot operators. So I guess maybe what we can start with is actually addressing this concern of transparency and whether malicious auctioneers are something worth considering, and how do we work around that?
I would just have one context question.
Mm-hmm.
Because before we talk about what auction strategy, I currently don't know exactly what we are auctioning off. So is it the right to produce one block that is?
Oh, sure, yeah.
Is this in real time, or is this like a block next week, or What exactly are we auctioning?
Yeah, let me set up the problem then. So what we have here is, imagine there's a block, some number of blocks in the future. This can be
a future block, not a
and it's in blocks in the future. It can be at the scale of hours or maybe even days, right? And so what we have is imagine like an Oracle update is happening on the block, right? So what happens is a single bidder will say, here's a reference transaction that's going to be in the block, and I want to submit a bundle of transactions in this order, either before or after this reference transaction. And so the goal there is the bidder is trying to inject their own transaction right after or right before this reference transaction, and they are trying to extract some value out of it. So they will want to bid, less than how much they value, but you can consider the game to be there's a single reference transaction and multiple bidders are trying to bid for their transaction either before or after this reference transaction.
So
Okay.
yeah, sorry, go ahead.
Yeah, so I have. Oh, Martin's still going. I'm sorry. Go ahead, Martin.
So sorry, it's still not clear to me. I mean, in my view, there would be two options. So one would be miner could say, well, I'm expected to mine five blocks in the next hour or something like that, and I auction off those future blocks, and you don't really know kind of what transactions will be there in the mempool. You don't really know. It's more like then it would be the average expected value of one block. That would be one option, what you could auction off. Or you could auction off something kind of in real time, where you see kind of right now with the given mempool, with the given state, with the given arbitrage opportunities, you could try to do this in real time. So I'm still not sure what of those two options we are talking.
So in the current implementation, I guess this is more a question for Alex and maybe anyone else on the engineering side who's still here. Are the current MEV, in the current implementations, are these auctions live for the next upcoming block, or are they for several blocks in the future?
Right. So currently you have to resubmit for every block.
Okay, so it's a live auction on the current upcoming block.
Exactly. So people, it's a first price auction where every bundle that is submitted for that block is competing with one another, and they're paying a tip to the miner in terms of using the block.coinbase. So currently it is different bundles that participate in this first price auction, and they price their preference with the tip that they give to miners. So it is competing opportunities, and it'll be the one that pays the miner the highest that wins.
Mm-hmm.
Does that make sense, Martin?
Yes. I'm just saying, kind of, there could of course be other ways. So you could say, a miner could say, well, I have a track record of having so and so much hash power, so I will likely produce 20 blocks in the next hour. So I'm kind of auctioning off 20 blocks already, and kind of you can buy them already for the next hour. And then, I mean, I don't know exactly whether I will deliver those 20 blocks, but well, maybe then it takes me not an hour, but an hour 10. Mm-hmm. And then kind of for those blocks, and you don't know yet which those are, but then kind of this one bot operator has exclusively already the right to, well, they already know they will get this block. Or, well, I mean, they of course only know when it's mined, but they know if this miner mines the block, then I will be able to build it.
Yeah, I think this kind of highlights the same question that I had, which is like the need for maybe like a meta framework stating the various different problem approaches. So I think the first thing we talked about, which is the auction off clear future block X MEV, is similar to probably the layer 2 MEV auctions we're going to have. So I'd imagine probably the optimism system is going to work like that. In terms of the layer 1 stuff, it is this more real-time continuous thing right now. So I wonder, another question there is how would the fungibility of the various kind of ARB transactions or the various bid transactions people want to place affect the auction, right? Because you may be able to, for example, have 2 of these bids that are satisfied together in let's say the clearing of whatever auction you have. But it may be the case that bid A cannot go through if bid B goes through. Those two are mutually exclusive, etc. So you might have like a very complex set of constraints on this like real-time system. So I wonder, like I know the Gnosis team has thought about this, but there's obviously like a trade-off there between like computational clearing cost and I guess fairness and the various constraints you can affect and how long the auction takes. These are all, I think, dimensions. So it might be good to like articulate this. And I think we do want to think about all these different types of auctions, but I think, so yeah, I think we do. I don't know whether the ideal solution is the same or different for these like block future auctions versus the real-time ones. Probably just slightly different.
Yeah, so that's very similar to what my questions were going to be. Just so for clarity's sake, well, Phil just said it. I mean, we need to be clear on exactly which sets of problems we're trying to solve with which auction solutions. And then related to that and related to what Phil said and related to Gnosis, the miner has a benefit in trying to form a block from the previous lost auctions. It benefits everyone for them because the computing of the block is going to be actually very expensive and complicated for the miner. And so if they can cache that result and get more rewards, that's better for everyone. And that needs to be a parameter that's addressed in the bundle itself. Like, does this bundle absolutely need to be in this block, or can it be in the next block, or something like that? And then, and so also another thing that I thought was interesting in your presentation, and thanks for giving it, is that we actually, this is a broader question about how folks see MEV-Geth being deployed. If each individual mining pool, let's just call them pools for the sake of sanity, they should be the auctioneers that are competing directly with each other, right? So their honesty is going to be, it's an open market. So we should assume that they're going to be, we're going to make one of these economic rationality assumptions, right?
Yeah.
Where they can sort of cheat, quote unquote, but we expect them to be able to compete on price as well.
One thing that may be worth mentioning for that Dutch auction Dutch auction example, if you're putting the computational weight on the miner in the sense where they have to propose a price, I fear that it might be beyond their capacity, because it sounds like it's a very hard computational problem, right? So asking the miner to like suggest, maybe they will do it naively at first, and then I guess the market gets more efficient as they find like better ways to find a price. But what you're essentially asking them is like finding all the potential MEV, and then that's like the like initial price or something.
Yeah.
Like this.
So actually along that line, one thing I wanted to bring up was, I think in the conversation in the past, one possible outcome that we did foresee was that there would be these intermediaries who would run essentially auctions for smaller transaction bundles, and then these intermediaries are the ones who actually take part in the auction with the actual miners submitting these larger bundles that they've sort of, that through their own auction they've sort of created. And one concern there to me really is that there is extra revenue there to be extracted, which I would wholeheartedly expect miners to try to capture as much of that revenue as possible. And does that mean that such intermediaries in the long term would eventually all just exit this system in favor of miners performing that task to, maximize how much they can actually extract? So here's an example I kind of have, right? So imagine we have two intermediaries, right, that run their own network of auctions, right, on small transaction bundles. Now imagine network one has two bids, right? One is a bid of, let's say, 10 coins, the other's a bid of 8 coins. Now imagine network two that has, that's being operated by somebody, has a bid of 5, right? So now each of these networks will report their own highest bid, right? Say 10 and then 5. And so now the top level auction, the miner will say, okay, if I'm going to run a second price auction, I'm going to say, okay, the winning bid is the network that submitted a bid of 10, but they pay only 5. Now, within their own network, right, the auction, if let's say network 1 that had the bids of 10 and 8, now they are paying only 5 coins, but they internally can charge their bidders their second highest price, and which in this case is 8 coins. So I wonder if there are if such opportunities for intermediaries to extract revenue exist, and whether miners, I think, would value the trade-off of doing extra work to essentially remove the need for any intermediaries and extract that revenue themselves. This thought I have is a little more vague than it is slightly half-baked at the moment, but that's actually something I just read this morning in a paper about intermediaries and how they work in ad auction. So I thought it would be worth bringing this scenario up.
I don't think that in this model you can have any intermediary besides the mining pool for a couple of different reasons. Mm-hmm. One of the reasons is the simple alpha leak, right? The intermediary will be seeing your bundles, and so the intermediary will be able to your point, extract revenue before you even get to the to the miner. And then so I think that just from a privacy perspective is difficult, and also in a similar vein from a sort of I don't know what the proper word for it is, but the contract between the bundle submitter and the miner, you can't really add another agreement in there, because then you lose that coupling, right? And so I think what you're really getting at is that the nature of the mining software, the pool software, will have to change. And the argument is that the pool operators themselves will need to have more CPU and of a different type necessarily than what they currently have to propose a block. So right now, a miner can propose a block with like a laptop or something, right? It's very low CPU. Yeah. But now, in order for a miner to maximize the revenue in the blocks that they're proposing, they're going to need some specific hardware configuration to be competitive. And so I think that that's actually fine, because it's going to be a little weird, but I think that ultimately that's fine. And it's also interesting because that hardware can't be distributed.
Right.
Oh yeah, I mean, I don't want to get started about 1559. Whoever, I didn't see the name on that, but yeah, let's pretend that 1559 doesn't exist for the moment, because that complicates things to a certain extent. And then I had one other comment with regards to, I think, well, I don't remember it, but yeah, that's it.
So I guess I have 2 comments, or 3, I guess. One of them is towards Rick's point. It would be good to generally develop a framework as maybe part of this deliverable and add this to the FRP of like, how do the very low level ETH system details affect our choice of auction, and like, do they require or impose any constraints, especially in the layer 1 versus layer 2 case. So I think that would be a good thing to study. I also, so I wonder, I think it would be cool in general to because I know you've been reading a lot of ad papers. I would love some like summaries or insights or pointers to cool papers if we kind of once we finish this discussion, but that's probably a longer term kind of question. And I also wonder, like, how is ETH arbitrage unique, like economically? Like, it seems like there are, for example, like certain use cases, and maybe we should enumerate in our MEV taxonomy. Maybe this relates to like the taxonomy of MEV, but let's say like hacks or something. What you have with hacks is like a very like sparse distribution of like a lot of value. So like you very rarely get like a very big kind of MEV opportunity. For something like a Dutch auction where you need to have like some sort of price estimate maybe let's say rolled over from before or something. It seems like those kinds of shocks would be would interact with that mechanism and like kind of So yeah, I think it would be good to also just enumerate, in addition to the low level details, just like maybe plug into the MEV taxonomy somehow and say like, are there any specific details of these MEV types that mean that we can't or must use certain auction types? I guess the only other comment I have is that I don't feel bad for bot operators who want to see like order types. I think we're going to have sort of privacy eventually anyway. So yeah.
That's actually a good point. Let me, I should be taking some notes. Let me just write that down real quick. Oh wait, no, this is all recorded right now. Okay, yeah, I think we're fine there.
Can I ask a more basic question again? What is currently the expectation that, I mean, miners could just like front run the bot operator, right? Or, I mean, like basically use something like a generalized front runner, and whatever submission they get, Phil, the example you brought was a hack where it's super juicy, where it's kind of 1,000 times higher than what the auction is paying. What prevents miners from then just front running the front runner?
Yeah, I mean, I think one of the things that we would like to build at Flashbots is, I guess, that privacy component. So last roast, we had some proposals for how to do that. None of them are fully fleshed out yet. But I think eventually we will have such a technique. In the short to medium term, I guess it's like a trust relationship of like which miners you choose and monitoring them over time, which is very suboptimal. So I think, you know, my guess is within the next year that tech piece should be done. It's not a terribly complicated thing to do, I don't think, at least to have a basic solution for that works well enough for this use case. But yeah, I don't know. It is a big problem. You're right. I think my concern with auctions that are in the clear, like what the bot operators really want, more PGA style auctions, is just that there's all these weird politics around like latency and who peers with who, and miners get lobbied to like sell their order flow and weird things like that. And I just think that if we have privacy, we can probably have a more efficient marketplace without any of that. But that's just a hypothesis. I would love to hear if people here disagree.
Yeah. While you were saying that, I was sort of working through, and I'm jumping in sort of late, so maybe someone's already answered this. But it seems like once you're in the private network of the miner and you're submitting bundles, I don't know why a price time priority auction would be the wrong auction to have. So there's this interesting question about actually forming the block and the interference between the transactions, which is again a very complicated, in the general case, an extremely complicated problem. But let's just say, again, for just so we have a clear discussion topic, I have two competing bundles. The miner needs to form the block as quickly as possible. That's still a requirement for them. So they say every 5 seconds, I'm going to pick a winner, and that's what's going in the block. And if you get in with the highest price within that 5 seconds, you get in the block, and there's not much else to, really sort out. And those batch auctions need to be very fast in order for the miner to facilitate the gossip that it needs to facilitate to get its block included. So I think that, and on the privacy side, again, I think practically speaking, there's just going to be Phil is absolutely right about, a blind bid or some other sort of system. I think in the moment it will just be the sort of nasty, well, the bots are paired with the miners and they trust the miner, and they, I don't know, just go, disparage them on Twitter or something if they cheat, I guess. I think that's about where we would be for a while.
So,
but even I
want to bring up maybe like a practical point of feedback that we got from Flashbots users already, is that, should two users submit two bundles that are non-overlapping in any way, it's a shame that currently there's only one bundle that's included in the block when both could have been included. From the Flashbot user perspective, it would be nicer for their bundle to be included if they're non-overlapping, and from the miner perspective, there's more profitability from taking two bundles in instead of one, right? So if we could I understand that actually solving this in a general fashion would mean finding a way to find like non-overlapping state or something like this. But maybe there's like naive bundle merging solutions we can start with, and then kind of iterate on that, so that the auction is more efficient in the sense where the tide rises for everyone.
Then, in my view, ideally you would communicate with your bundle to some degree what parts of the state your bundle is touching, and if you if you don't, I mean, or in many cases you can pretty precisely say, okay, only those 7 contracts or so 7 contracts are read from or written to, and then if another bundle doesn't read or write to those contracts, they definitely are not, but they definitely could be included. Both of them could be included. And I know that you can even do this with static analysis, or Alexei knows much more about it, but you can just by looking at the transaction and looking at the opcodes of the contract they're calling, you can already get good knowledge about what state will be read from.
Yeah. So, I mean, like even in the current Flashbots like implementation, or sorry, the MEV guess implementation, I think like an even more naive approach can just be, right, like that in the upcoming block, there are essentially for any number of n, for any reference transaction, right, like the auctions to submit a bundle around that reference transaction, as long as can be considered just completely distinct auctions altogether, right? Like if I have an Oracle update and people submit their bid saying, okay, my reference transaction is this Oracle update transaction, and I want to be, in this location relative to that transaction, and somebody else submits, saying, okay, this other transaction, I want to be, in this location relevant to this other reference transaction. So even a naive solution can be that for all the possible transactions that will be included in the block, treat each of them as sort of a reference transaction, and that just becomes like an independent auction. So you can have essentially several auctions ongoing for different reference transactions. The problem there, of course, is that you're going to run out of block space eventually. So you do need to. So the block producer does need to at some point consider, right, which ones can even be included, and so there, it just becomes whichever of these reference transaction auctions yields the highest, the highest revenue for them. One thing I do want to say and go back to Rick's point was that even with privacy, like you're saying that these bot operators can go on Twitter and complain that some miner is not acting as they should, and this and basically rely on just trusting the miner. But my concern there is that with sort of high privacy in the auction, can such malicious miner behavior even be detected, let alone somebody going online to complain about it? And it can be something as simple as miners injecting their own bids into an auction in order to inflate the price.
I wanted to just suggest that obviously the problem of computing generally, kind of what affects what, which transaction affects what, is large. I mean, I wouldn't say intractable, but it's very computationally intensive. So one thing which could be tried is to reduce the space of all transactions that are kind of accepted for the auctions. For example, to see whether this reduction will still bring the same value to the users, but this reduction may allow much more efficient computation. And so one specific reduction I would suggest first, as unfortunately we haven't implemented this yet, is that essentially when you are looking at any transaction, so you try to execute it in a slightly modified version of EVM, in which it basically, most things runs as they do, except that the sload and store instructions work in a different way. So store essentially does pretty much nothing. It blows up if the address value is undefined. So we basically, in the stack of EVM, values could be either concrete or, let's say, undefined, something like this. So the store basically blows up if address is undefined, but otherwise it does nothing and just remembers that, okay, this particular cell has been written, so which basically populates the right set. On the other hand, sload also blows up if the address is undefined, but if it's defined, then it also does almost, apart from putting this undefined value on the stack and remembering that this cell has been read. So this particular execution does not touch any state pretty much, and can be processed, I mean, pretty quickly in parallel. If you have enough CPU power, you don't have to have a state. So I wonder, like, the class of transactions that that could be run like this without blowing up on those undefined addresses, I mean, probably quite rich. And then if you have transactions which are in this kind of class, you can pre-run them in this particular modified EVM, and you can figure out their reads and write sets, and you can figure out which ones are affecting the others, and then you can basically figure out which ones could be done in parallel, which ones could be reordered and stuff like this. So, but we don't know yet whether this reduction actually removes some usefulness for what people are actually doing with MEV. So I don't know how these reductions, they affect the MEV, because if the auctioneer or somebody else or intermediary, if they wanted to have a more efficient system, they could offer to the users, okay, look, guys, we only accept actions which could be run like this, but hopefully this is still good for you, but we can basically process them in much quicker fashion.
That's an interesting point. Sorry, go ahead, Alex.
No, I had an idea. Maybe it already works like that. I didn't know that indeed it's only one bundle that can be included in a block at the moment. But perhaps quite a trivial improvement can be that to keep some kind of a stack of the MEV that the bundle extracts, and order them in the order of how much MEV does the bundle extract, and every time that you include a new one, replay the bundles and kick out if one of them suddenly returns 0, maybe it or whatever, or returns a value low enough that it's not no longer profitable to include it. I'm not sure if that's how it already works, or if is it complicated or to implement it like that.
I would say that if you do it in a sort of in a general, kind of what you would say quadratic complexity is that if you already have certain number of transactions in a bundle, let's say 100, and you try to test another one, you have to re-execute all 100 again, and then the new transaction comes, you do another 100. In the approach of reduction that I just talked about, you don't have a quadratic. It's basically it probably would be linear or and log n, because what you do is you already, for those 100 transactions that you have, you've already computed their read-write sets, and all you need to do is to run a new one, figure out their read-write sets, and compare them. And so this effort is actually not going to be quadratic.
Yeah, that makes sense.
And another thing is that it doesn't require access to the state, which is also not. It's actually quite a big deal. Yeah.
Phil, you were going to talk. You were going to say something. Yeah.
So I guess there's a few things that come from. So I agree that this merging is a big open question. I don't think like only having one winner per block is the optimal option. I think we can make that argument pretty easily. I wonder a few questions. Number one, like, would it be better to have multiple auction types where, let's say, one is like you just have one winner for each block, and another one is you can have multiple winners, but they have to conform to this kind of static criteria where you provide the state upfront, or like they're easily statically analyzable or whatever it might be. And then you kind of have these multiple auctions that like form a meta auction that like bid against each other, where like maybe one block, this like transaction which really has to happen by itself is just way more MEV, and that's fine. But like another one, these like 30 DEX arbs together kind of that don't conflict with each other override the like one mega thing that like screws up everyone's state. So I wonder like how multiple auction mechanisms together kind of interacts with this.
And your second question?
I forgot it while I was saying my first one. I was hoping no one would remember it.
But I wanted to, I mean, I don't know the answer to this question, but I would suspect that it is still kind of lucrative and profitable. Then I would suspect some kind of ecosystem are springing up in here, because as you just said, Phil, that if there are different sort of reductions, if there are different constraints that you can place to make your stuff more efficient, and then you can announce these constraints to the users, then users will say, okay, what is the tightest constraint that my use case still works with? Because I probably the tightest constraint would lead to the most efficient auctions, and then I will go there. And so each user will choose whatever the tightest constraint that it can satisfy and go there. So for example, the super general one would be where everybody can fit, but it's going to be very inefficient, and maybe they will only get a slot once every 100 blocks. But the ones which are super efficient, they might get a block like pretty much like immediately or something. Like if you win the auction, you get straight in. But you can run only very restricted types of transactions. So yeah, maybe that's how. But we cannot, I think, predict from the start what these all different types would be. So I guess people have to figure it out and compete about it.
Yeah, so I think building a modular system and experimenting is definitely something we're trying to push for. So maybe that's a good also first approach, is also figuring out like what data we want to gather from experiments in this first round, because we kind of have this system and we can deploy these multiple types. Plus we have auctions that are already running that we can get data from. So it might be worth just figuring out as another deliverable, Surya, not to pile on, but I guess that's what these calls do, is like what metrics do we want to measure and publish and like have people exposed to researchers and things like that. And I remember my other question is just like, I wonder, so in this adversarial environment we have, if we have this constraint-based auction system that kind of Alexei and that we've all been talking about in the last few minutes, I think you'd also need to have some mechanism to like enforce these constraints. So you'd probably need like a wrapper contract where like, if your transaction is mined, but the constraints are violated, you don't end up paying anything, so that the miner can't kind of like steal your fee payment. I don't know, there's all sorts of concerns like that. And also that you don't like lie about your constraints, right? So like, if you lie about your constraints, you should somehow be penalized for that too in this auction system, because otherwise it's a DOS vector.
Yeah, that's quite kind of interesting.
Yeah.
Yeah.
I also wonder, not to put you on the spot. Sorry, go ahead.
No,
yeah, I was just going to say, not to put you on the spot, Ben, but I know you guys are building an auction, and I wonder if you've thought about these things or what your internal thinking is. You don't have to say anything if you don't want to. I just thought it might
no,
be interesting.
it's all vibing. It's definitely everything y'all are saying is vibing. It's vibing hard. It's interesting, this whole notion of the static analysis and sort of multiple compatible bids being included in a single block. It's actually notable that this approach has implications for scalability too. So we're like doubly thinking about this, because the same property that would allow you to have an access list checker that allows you to make sure that transactions don't intersect can actually allow block verification to happen in parallel too, even outside of this like bidding gas strategy. So that's one comment. And another thing that is interesting that's been coming up here in discussion that I haven't considered in the context in which we're building, which is layer 2, is this notion of the fact that we have miners individually running MEV geth. Surya, one of the questions that you started with was like, what are the, like, basically talking about the desirable properties of PGAs now. This is an unknown hypothesis to me, but my suspicion is that one nice thing about PGAs is that they're a single marketplace. And so we similarly have the ability to build a single marketplace for layer 2. It strikes me as an interesting problem on layer 1 that like to do like all the miners running MEV guess, like Dan, you brought this up as well. Am I bidding to every single one of them? And like, if not, am I just like losing out on, whatever percent of the hash rate I'm not bidding, towards?
Well, I think that is a problem you guys will probably have to deal with also, because there may be multiple layer 2s, and it might be the case that like whoever is bidding in your layer 2 might also be bidding in other layer 2s, and they might be placing their bid based on how much they expect to be able to extract from like cross layer 2 arbs on like multiple competing systems. So probably understanding
those you got me.
Also, yeah, be important.
That's an interesting point. Yeah. I guess that would be, do you think that would be specific to these strategies? Because one thing we were saying earlier is that like it makes sense to have auctions that are like sort of confined to particular strategy types. Like it makes sense that there's a front running style auction where you're just caring to get a transaction in before, before another one, versus like the hack thing where you're like, I mean, maybe you're still trying to get in before, but it's just like this big opportunity that comes up. So I wonder if there are first order things that can prevent that problem, because like front running is front running and it's on one chain and you're beating the liquidity at this one point in the state space.
Yeah, no, I think that's an open question. I don't know. That's an interesting thing to study.
Oh shit! Hold on.
The other thing that I will
the opportunity.
Oh yeah, someone go use Siri's laptop while it's still logged in. The other thing which I'll throw out just to share some of the layer 2 context that we at Optimism are coming from. Okay. We honestly have like 2 layers, like 2 considerations going on here. One of them is that we have a layer 2 system, and we have the ability to auction off, like on layer 1, the ability to produce blocks. And the second one that we have is once someone has that ability to produce blocks, it still seems probable that the person who's best suited to producing blocks and like doing those layer 2 things would still want to go to front runners, like, front runners and other like, bot operators and say, hey, can you help me choose this ordering in a profitable way? So we've like published more on the former, which is like have some sort of auction system that makes you become a miner, or at least what's a miner in the context that we've been talking about here. So I just thought that's worth throwing out. We kind of have 2 layers of this. We have like something that's replacing mining, and then we have the same problem that you guys are working on at the layer of mining.
Yeah, so I think that you so I think that there's a different there's actually a slightly different problem for the L1 Optimism on L1 is that you actually want to have a long-term contract with a miner that guarantees that they will include your transactions, right? You want to be able to have some sort of proof that whichever operator submits the transaction, that miner or some set of miners will guarantee the inclusion, because that will like stop a whole class of attacks. And that's like, I think, a very different contract than what a PGA participant wants. Like to the point where it's worth calling them out. And then my other comment was, Phil was saying, or Ben, you're talking, I don't know, actually I'm not sure who was saying it, that one of the benefits of the existing PGAs is that it's one marketplace. And I think that like very literally what we're talking about in this conversation, like the whole point of MEV Geth is an acknowledgement that that space is fracturing, right? That it's necessarily going to fracture. And like that's like essential to the discussion, is that the different percentages of hash power are now basically we're converging to a world and I will mention 1559 here because I've thought about this. If you add 1559 and you add MEV Geth, people, there won't be any more transactions in the mempool. You know, any transaction of any value, there'll be weird, cheap BS in the mempool, and anything of value is either going to go to some miner. And so I think that, you know, I don't know that everyone's really thought through. Obviously, this is a call where probably more than the general population, we've certainly thought through the implications of that. But that's the direction that we're going in, and we just have to accept it, basically.
Yeah, I totally agree. I think the only reason that it's one marketplace is that that's just what the software does out of the box, but the incentives are definitely there to change it, and that is starting to happen, and it's been happening, and I expect it will continue to happen. So yeah, I think it's more about understanding the emergent properties of this like already chaotic marketplace, and like understanding like what happens if we can introduce privacy, and how can we reason about these channels, and how can we, if we do introduce privacy, can we still somehow create a single marketplace out of these multiple smaller marketplaces? Like my hypothesis is maybe like if you have kind of private bids that can be passed around the same way mempool messages can be now, I think your advantage as a large trader is to use a network like that to access more hash power if you trust it to work. It's better than the mempool where like anyone can front run you. I think that's yeah. But we could also easily end up in a universe where it's just like a bunch of miners having their own fiefdoms, and yeah, I would personally like to prevent that, but it's possible.
I think with privacy in there, I think the hypothesis that I probably think is most likely is exactly that. It becomes a single marketplace where you just distribute your bids over as much hash power as you can, and then you can essentially simulate the mempool environment without front running. I think that's probably the more likely outcome than just having like you said, minor fiefdoms that sort of split the market up.
Can I ask?
Sorry, go ahead.
Can I ask maybe a slightly naive question from having missed conversations about how this privacy works? Like, is there a straw man for how you would implement this privacy, and like, why does introducing privacy not nullify the whole like, won't users use that privacy to keep themselves from being front run by these bots, in the same way they're preventing each other from being front run?
Yeah, I think they will. They will do that. There will still be space for bots to do things. Like there will still be bots that, for example, respond to market conditions and things like that, or otherwise have like inferences on user order flow, the same way you have them in like the traditional market, where like it's not the case that every bot on the stock market can see your order book before it hits like the New York Stock Exchange or your orders, which is like kind of the ETH world of like an open mempool setting. But at the same time, there's still opportunities to take advantage of asymmetries and other things kind of that don't directly come from just seeing the order before it's placed. That probably will still exist. So I'd imagine, yes, to some extent, users will do that, and like part of the bundle combination and all this stuff we've mentioned will be part of that. But there will still also probably be some cases where like there will inevitably be bots. Like liquidating CDPs is a good example of something that's on the network today that like, anyone can do it, but like still only one person is gonna end up profiting from that. So there has to be some like mechanism there to make that happen.
To sort of go.
Sorry, go ahead, Rick.
Oh, I was just going to say, are we considering like some sort of like ZKP based block formation in terms of the privacy stuff? Because I'm having, I think I'm kind of with Ben, I'm having a difficult time imagining how this privacy stuff could work, and also isn't it sort of a base layer protocol change? Like it's great that we're all talking above the protocol layer, and I am happy to stay there. But if we're talking about a privacy mempool, how do we achieve that? And to Ben's point, I assume it's not SG. I would assume it's not SGX actually. So I'm curious.
I think SGX is a good straw man. So we had a few different alternatives that we discussed in the last roast. I don't know which one of them are feasible. Like the ideal would kind of be like a MPC, like with the miner, possibly with like a neutral arbiter who could like ensure data was available. Basically, the problem is the user wants to place a bid to the miner. They have to prove that their bid is valid, and they have to prove how much the miner is going to get paid from their bid. And the miner wants to know that if they actually mine this hash, that the block will not be useless, that like A, it will be valid, and B, the data will be revealed quickly so that they can profit from actually mining the block and they're not penalized on the network. You know, I encourage you guys to join these conversations, but I think SGX is pretty much the only solution that works without economic bonds and like crypto economic assumptions. Honey Badger could work. You would have to run a whole ETH client in it. And the problem is that like any penalty on the miners latency is a penalty on their economics. And so the MEV would have to be really high for them to take that. I will say that I think you can design a network with SGX or trusted hardware such that if that piece breaks or is compromised, the only thing you will do is like fall back to PGAs. So like that would be the ideal. That's the straw man, like assume it works. But I would love to have more conversations. Like I don't want SGX in the network long-term personally. And like maybe a solution is like a more specialized smart contract language that is like more natively suited to zero knowledge proofs of like validity, or some other static proofs of validity that maybe will come anyway from like various scalability changes might make this easier. I don't know. Long term, I think this is very much an open question, but I think one straw man is use SGX. You can do it. You can develop a private system that, as long as SGX doesn't break, it works. And you know, I think that will still probably be more efficient than the mempool and then individual miner auctions. But I'd love to hear your thoughts. And also, I have a hard stop in 9 minutes because I have to catch the last chairlift. So I really love these conversations, but just for the record, I'm not leaving because I don't love you guys. Thoughts, flames.
I have lots of thoughts. I'm muted with thoughts. I agree with your argument about SGX in the short term. I think that if we're going to add ZKPs at the protocol layer to make this sort of composability assertion that we're talking about, we might as well just fix the EVM. I mean, it in some sense, it's a back door into saying, well, we need to fix the composability in the EVM, right? Because we're really talking about why is it that these transactions don't have to take semaphores in order to mutate the shared state, right? So I think that's a really, I can barely speak. I think that's a really deep question, because essentially what we're acknowledging is that you know, we're at a point now where we're like, okay, the shared memory of the EVM is really broken to the point where it breaks like everything. We have to go back and fix it.
I think that might be a point that sharding will maybe take us to anyway, because I also just don't see like I think things get really weird with like PGAs and like dynamic memory accesses and RBOTs, X like sharding, X like possibly shard gentrification, X like whoever decides ordering of transactions between shards, or like which cross shard transactions get priority. I think there's a lot of like really ugly edge cases that will have to be looked at. So I think you're right that like long term, that might be the only solution, is to like think about composability more generally, which is to be fair what the Bitcoin maximalists said would happen. So maybe they deserve some credit for that, but I think that was, yeah, I don't know if exactly I don't know exactly what the memory overhaul is that will be a solution. Like I don't think it's as simple as like just go to the UTXO model, because I think that there's a lot of trade-offs there that need to be thought about. But yeah, I think this deserves like a much deeper, longer conversation also about the long term.
Yeah. To prevent Rick from getting started at raging at the EVM any further, and to catch you before you go, Phil, I do have one more question to loop back on an earlier comment you made when I asked about privacy. So it definitely makes sense to me that like there's lots of slow market arbitrage opportunities, even in like a very private mempool regime. I guess my question then is like, to me, it seems like the current MEV-Geth implementation is very much not very well suited for slow market arbitrage, like strategies or like preferences. So I do wonder like how careful we have to be in trying to design a system for privacy when if the system has privacy, it like fundamentally changes the the preferences of the participants.
How does it change the preferences of the participants? Say like, using MEV-Geth now, when they submit their transactions, the miner can't see the content of their transaction before it's mined. How would that change the auction, for example, or?
Yeah, I guess the example that I'm thinking of, and yeah, definitely correct me if I'm off the mark, but an example I'm thinking of is just like, okay, let's say there's a private mempool. Now I can't front run a Uniswap trade. So the way that I'm going to extract value from Uniswap is I'm going to look at the price of off-chain exchanges with lower latency and try to arb against those off-chain prices I expect, with where the off-chain price seemed to be in the previous block when I could see it.
Right. So I think to some extent, having a privacy system makes market a little bit less efficient, where you're pushing the efficiency back to the next block. You still have different liquidity pools within DeFi, and if you have like a price dislocation in a Uniswap pool, then someone would arb between that SushiSwap pool and Uniswap pool. But instead of front running an order, sandwiching it, or back running an order, you wait till that order whatever price actually lands on chain, and you push that price on chain before executing your transaction. That would still happen, right? Because you still need some kind of like price efficiency, and there would still be opportunities there for people to do so. But to some extent, with a fully private system, to me, it seems like you're pushing efficiency back to the next block in a way, if that makes sense.
Yeah, I think so. Okay, I'll have to think about that more. I think that's just like a generally open, like fascinating question to me. Is like in this private regime, what MEV opportunities disappear, what ones appear, and like what ones remain.
Yeah, I think
definitely
that's
you
part
wouldn't
of
have
like
back running, right?
Yeah, I mean, you
So,
might have
right.
dynamic back running where like you spam transactions that like check dynamic back running conditions kind of on the chain. But I think that is definitely like we need like a 4D matrix of like MEV types, X like auction mechanism, X like layer 1, layer 2, X like EVM internals, and like how do all these things kind of interact in each box. So I think that's definitely a clear deliverable is somewhat forming.
I totally agree with Phil. I think you're going to see like statistical art, right? Where maybe there's like patterns you can discover in like price discrepancies, or even like Oracle updates, and then you can like submit those without having a view of the actual transactions in the mempool. So maybe there'll be like strategies there.
Yeah, I imagine there'll also be arbs of the form like I send this bundle. I don't know how much money the bundle is going to make. It could make 1 ETH, 10, 50. But I have some model for how much this will make on average, so I'm going to bid according to my model, and kind of subsidize that. So those kinds of bids could exist one day in more probabilistic, like on-chain logic style arbs. I think that's worth considering in this taxonomy also.
I want to maybe bring up another question again, bringing it back to searcher feedback we got. So bring it back to like the current system that doesn't have privacy, and privacy is not something that seems that is implementable in the short term. I think if you're running a Flashbot searcher and you're using a Flashbot system, the main recurring question is like, how do I set my tip, right? Because a normal bot operator is used to looking at the mempool, looking at other transactions, and then reactively bidding. And doing this kind of PGA activity that Phil described in Flashbots 2.0. in that system, it's a first price seal bid auction, and they don't necessarily have a way to determine their bid. And my answer so far has been like, you can look at similar transactions historically and the tip, the successful Flashbot bundle and the tip that was given, and then you can maybe from that make an edge. But where they don't know if they could have bid lower or not, and they don't have a lot of information for them to understand that, I think. So yeah, just bringing that up. See you, Phil, by the way. Enjoy the skiing.
Thanks, guys.
Do you have already some empirical data on the auctions that have been running so far? So I mean, like, is the tip, is it like the average gas price, or is it 10 times the average gas price, or it's 100 times, or just very roughly what's going on?
We have some data. There's nothing that I can say conclusively. I don't know is Scott on this call? Scott, if you're here, show yourself. If Scott's not on this call, it's definitely something we can dig. The problem is,
I'm on the call.
Scott is here. So.
Yeah, I mean, there's right now the number of searches we have is it isn't so large that I think that there's a lot of competition, especially for the same opportunities. We've been really, ensuring that we have a wider support for MEV strategies than competition. So I don't think we have a full picture of that yet. I mean, they are taking MEV opportunities that are available on chain, and I think we could probably get some data about that, because there is some information asymmetry for those that are participating in Flashbots, that they still need to beat the vanilla ordered block. And so, yeah, it might be interesting to get some of that data about how Flashbot users or even Tai Chi users might be benefiting from this, seeing the bids of standard transactions while others can't see their own. Oh yeah, we haven't looked into that yet.
Right. So as Scott was saying naively, the minimum bid you need to submit is enough so that the Flashbots block is more profitable than the vanilla block that a miner would mine, right? But then that's in the case where you're the only one submitting a bundle for that particular block. As soon as you have multiple bundle submitters, what do you bid? Do you just, increase the bid and hope it works? Or if it doesn't work, do you just keep on increasing until it works? I'm not sure. I mean, I'd like to have a better answer for bot operators, and something that's also more helpful to them than just basically like throw a dart in the dark and hope it lands.
I think that's just more to the point why, like, current level, why mempool PGAs are sort of, why they work, right? I mean, like that being able to observe others betting strategies seems to be something very important to bot operators. Even to the point, I would argue that, without it, they would likely, stick to mempool PGAs over, some sort of MEV geth auction.
So the interesting question there is, the miners would, I think it doesn't, I mean, if the bots want to try to stay on those on that hash power, that's a fine option for them. But if more hash power moves towards privacy, it sort of happens regardless of what the bots want. And I think that they'll just be there's certainly certain types of ARBs. I mean, I think that bots will end up paying maybe not the majority to their miner, but a significant amount. And there's probably some interesting game theory there, given the distribution of hash power. So I think that ultimately effectively what will happen is the MEV supporting miners and the searchers will be colluding against the non-cooperators to push them out of the market.
One thing I will add to that is something that we had fought before is it's definitely kind of to be expected that the tip for the as the markets become more efficient and a strategy becomes more known, or an arb in particular, or a discrepancy becomes more widely known, the tip will increase, right? Because more people will compete for it, and so they'll be willing to give more and more of their margin to the miner. But then what we imagine potentially happening as well is, because miners select the most profitable bundle, you could bundle several opportunities within your bundle. One, like for example, the one that's widely known, you give 100% of it, and then you have another one in there that's less widely known where you give a smaller tip, right? So you might be included several opportunities within one bundle to just maximize the bundle profitability. And so you have these weird potential, because I mean, a bundle still has a fixed size, right? It's still, I guess, limited by you can't submit a bundle that's larger than a block. And so there's only so many strategies. So maybe there's like a churn or like a cycle in tip going from like 100% to maybe less when there's other opportunities that are more profitable, and then coming back in like the bundle mixing. Just putting it out there.
Yeah, I think there's also the question to your point about that oscillating price. That's also a reason why miners might offer a side deal to reveal the previous bundles to other bundle purchaser, other bots, right? I think that's something else that we have to put into the model is, even if it is a commit reveal, you have to assume that the miners are going to turn around and sell that data to competing operators, competing bots.
It's actually a fantastic point. I think that's probably going to be, that seems probably actually to be quite likely. I wanted to ask you, Rick, on a point you made, I think 2 points ago about miners and bots sort of working together to push out non-cooperating bots. Can you elaborate what how exactly you define non-cooperating bots? Are you saying only those who end up like sticking to mempool PGAs versus actually adopting MEV Geth and performing those auctions?
Yeah, that's exactly what I meant. Yeah. So if you're just in the PGA auction, you're going to be revealing there's this whole other group of people that are effectively in this very odd way cooperating against you. Yeah. And you're revealing data to them, and they're not revealing data to you. So yeah.
I get it. Okay, that makes sense. Yeah.
Cool. We're about at time. So I think we're going to summarize, I guess, some of the TLDRs from a lot of really cool brainstorming from today. But I would love to follow up with a lot of our new friends on the call, especially Alexi, Martin, Rick, and everyone, and Sam, everyone here, for your comments. And actually, I think we would like to host another more structured discussion on block space auction design at some point in the near future, to kind of pick up a couple of the, I would say, more of the low-hanging fruits, and also do it in a more systematic way, maybe mapping out the 4D chess as a starting point before the call, so that we could kind of dive into it and weigh the trade-off within the design space. I wonder how does everyone think about that idea, to kind of in the next couple of weeks find a time to dive deeper into this question, so that we could actually come up with, I would say, a more holistic view rather than just open-ended questions.
I mean, I would definitely prefer the kind of the discussion about specific topics. The more narrow the topic, the better. Obviously, but yeah, I try, not to have too many calls, but definitely I could spare 1 hour or something like that over the next 2 weeks. But yeah, so we basically, yeah, I think it's fine for me.
Yeah, that would be fantastic to have you guys. I think we will be able to we'll draft the agenda and share it with everyone before the call to see, because I think everyone here on this call brings a very unique angle. And in particular, I think a lot of us are a big fan of work from by the TurboGeth team, as well as big fan of work from the Open Ethereum Collective, etc. So like I think a lot of we haven't really been able to dive deep. Like we would love to kind of have more of that exchange from essentially the creators, like builders who are actually providing these core instruments that the current block producers are using. So I think that's a very unique angle. And so, yeah, thank you guys for being on this call, and we'll follow up with you. I would like to, if you guys are not in our Discord group, we can share it afterwards, or you can find any of us on Twitter. Yeah, whatever is the best way if you're not already within our community. Cool. Okay, well, all right. Soraya, any closing thoughts?
My closing thoughts are actual. I've been sort of trying to write them out in the chat as well. I think 2 points to really take away and think about for, I think, maybe next week or the week after's research workshop is, one is what Alexi had brought up of these sort of smaller constrained auctions, and using them to aggregate, as many target as many bundles as we can into the block, based on what sort of state space they touch. I think that's probably worth exploring for a future call, and just sort of trying to flesh out that direction as best as we can. And also the 4D axis that Phil kind of identified for classifying not only the auction mechanisms that will work out, but also how they're impacted by low-level protocol EVM constraints. I think that I will probably talk to Phil more about after the call's over, after he's done skiing, and I'll try to maybe flesh out such an axis for our next research workshop that might sort of illuminate more precise design choices. But besides that, that's I think only closing thoughts I have. I think the smaller auctions, constrained auctions, is, like in my guess, I think probably the most fruitful direction to at least explore. Yeah. Anything else? That's about it.
Cool. Well, thank you all for joining. This was great.
Yeah, thank you so much.
Thank you. Bye.
Yeah, thanks.
I had a really good time.
Contributions and Rick. Yeah. Thank you.
Right.
Bye.
Bye.